So here we have the GelSight Mobile Series 2 system. So the GelSight is used to characterize surfaces. So whether that be a surface defect, surface roughness, a radius, a chamfer, a break edge, hole diameter, the system is used to characterize those kinds of features and give us a report or a template to report to capture that information so that we've got traceable data to suit the current industry standards within aerospace, automotive and high precision machining. So the system itself is a 5 megapixel camera. We've got a lens and then a ring set of LEDs. So as an example, when I place my finger over to the end of the sensor, we can see that we get an instant surface depiction. By clicking the black button on the sensor, we can see that each individual LED position lights, and we effectively take a photo. So using an algorithm called photometric stereo, we stitch those images together to create an STL file. And that STL file is what we use to create those surface characterizations. So whether that be the roughness, our pitting, depth of mark, but we use that data set to capture that information to create a report to understand what's happening on that surface. So within the latest version of the GelSight software, we've got something called defect detection. So effectively the way that this works is we can define a boundary within the field of view of the pad, and if we place a defect into that area, it will automatically detect it. We'll characterize the length, the width, the depth and the volume automatically. The main benefit to this change is that we can run the routine automatically within the software. So if I place the pad against the surface and click the button, it'll automatically do all the information for me. I don't have to draw any boundaries or anything like that. So what I'm going to do is in the software, I'm going to click Run Routine, and I've got a 50 micron tolerance limit for my effective zone 1. So on my component, I'm going to go and take a scan, place the defect into the field of view, and click Capture. So that's effectively all I need the GelSight for. I've taken my capture, and now the system is creating my STL file, and we're going to be able to do some analysis. So you can see in the top right corner, I've got scan 02, which is the scan of the sample that I've just taken. You can see we've got a green box around it. That actually tells me that it's past the zone limit of 50 microns. So if I double click into here, you can see that we found the defect. We found all of the other little defects on the sample, which are these grey areas. And what it's done is it's automatically profiled the sample in the worst case area. So you can see here in the top right, I've got my length of 6.433 millimeters. I've got a 0.762 millimeter width, area, volume and depth. So now as an operator or a user, I would just need to go to the PDF button, and there's a report of all of that information. So I can save that onto a network or export it, print it out, stick it to a tracker sheet for the defective part. But it's a really good example of how I've gone from there's a defect on my sample within a specific area that I need to tolerate or understand. Within 3 clicks, I've got a report of a traceable set of information that we can use to understand a little bit more about that defect. We can use the GelSight system to measure radii. So what I'm going to do, nice and quick, is take the system to the end of this larger part, place it against the surface, and we can see the radius. Click Capture. So whilst that's analysing the data and creating that STL file, we're starting to see a lot of our customers that manufacture larger samples, so this is an example of one, that they're struggling with having to take the sample to a inspection machine to be able to measure things like radiuses, break edges, chamfers, fillet reliefs, that kind of thing. So the idea behind using the GelSight system is we can bring the system to the part as opposed to the part to a measurement system. One of the benefits to that being that if I manufacture a 3 meter long part and it's wrong, I don't want to have to put that back into my machine tool to rerun or blend out any of the radiuses that potentially could be wrong. So the idea behind the radius function is, in the bottom left here I've clicked my radius, I draw a profile along the radius, and you can see the system snaps the blue boundary to that radius to output us a result. What we can also do is if we go to the pencil, we can add in a number of radiuses. So if we said 11, and then I went to do that over a 0.5 millimeter area, and we click Analyze. Now what this has done is we're looking at the change of radius. So over a 0.5 millimeter area, we're looking at each individual radius, and we're outputting the worst case, or the minimum, the maximum and the median radius. So that gives us an understanding as to whether potentially the tool's wearing or there's a drift in the machine that's actually cutting the radius itself. Using the GelSight Mobile Series 2, we're able to capture profile roughness and surface roughness. So the capability of this equipment is to measure between 2 and 20 RA, but using the GelSight Max system, we can characterize between 0.2 and 20 RA. So it's just something to note. So in the bottom left-hand side of the software, I can go to Run Routine, and I'm going to select my 10 micron SA measurement. So now the same principle again as our defect detection. I can place the system over a sample. So this is a 3D printed texture. I can click capture. And we're going to characterize the surface roughness, or the SA value, within that boundary. So the system can characterize other surface parameters, but the main one that we're currently seeing customers use is surface average. So you can see here we've got a plot of the surface roughness. I've got a pass because it's below my 10 micron limit, and you can see the other parameters that we're currently exporting with some blurb and information as to how that's been characterized. So when we're now looking at profile roughness, what we can do is go to my profile roughness tool, and in the same principle I'm going to draw a profile across the sample like so, and we can now see we've got our profile roughness. So in a similar fashion to the radius, we can do a number count. So let's say we're going to do 15 over a 1mm spacing, and I'm going to click Analyze. So we've now got 15 profiles, and we're outputting the average RA as well as just the specific RA for that individual profile. So if I wanted to report these, both of these measurements, I can go to my PDF and save. So as a first instance, we've got our SA and the other surface characterizations. We've got our movable PDF, so I can set that to that position. If we scroll to the second page, we've got our movable heat map again, as well as like showing where I've taken my plot for the profile roughness. So it's a very quick overview, but as a principle it shows how we can characterize surface roughness as well as profile roughness using the GelSight Mobile Series. We can use the GelSight system for dimensional checks. So on the example I'm going to run through here, we've got a hole diameter as well as the angle and the length of a chamfer. So I'm going to bring the GelSight system to the hole diameter to start with. I'm going to place it over, and I'm going to take a capture. I'm then also going to take a capture of the chamfer, which we can see nice and clear there. So if we were to look at the hole diameter first, I can go into the software and I can click hole diameter. I can draw the boundary of where the diameter is, and the software will find the edge, and it gives me the diameter as well as the circularity. So we can look at reporting this. So if I was to go to the PDF function and click save, we've exported a report of the information related to that diameter. So now what we're going to do is jump back into our Scan 06, which is our chamfer measurement. We can see here we've got the chamfer. So what I'm going to do is I'm going to go to the drop down and I'm going to click on profile geometry. So what I can do here is I'm going to draw a profile that just surpasses the edge of the chamfer, and we can see here that we've got the shape. So the blue boundary is the area that I'm using to review the chamfer. What I also need to do is to level the left hand side, which is subsequently the flat edge that I'm assuming the angle from. So the chamfer starts at the area where my blue boundary is here, and it finishes where the drop-off point is in this direction here. And we can see that the chamfer, which is the x1 to x2 distance, which is the blue point here to the red point in this axis, is 1.287 millimeters. We've also got an angle of 37.62. So if I was to go to the PDF function now and report this, we can see that we have the chamfer, we've got the information related to it, we've got the heat map, as well as the profile and the information down the left hand side here. Using the GelSight system, we're able to quantify the size and number of particles within a field of view. So what we've got down on the left hand side is some coffee grounds as an example for what we could use as particles or explain the particle function. So I'm going to take the GelSight system, I'm going to place it over a section of the particles, and I'm going to click capture. So within the software, we're creating our STL file at the minute. So the system is currently taking all of those images that we've taken and creating that point cloud. So now I'm going to load scan number 7. Click OK. So in the bottom left, I've got my particle detection. I'm going to click particle detection, and that is automatically going to run the routine to find those individual particles that we see on the surface. So you can see each individual one has been colour mapped, and on the side here we've got the size of those being reported. So we can see every one of those individual particles, where they are, the area, the centroid and the X and Y orientation, and it gives us a lot of information on that specific surface. So for me to report that, I can go to my PDF button, generate the report, and I'd like to save those changes. And you can see that we've got the heat map of the surface, we've got the actual particles themselves, so we can review some of the specifics, and then we've got the number of particles, percentage covered, minimum, maximum, and the max particle amplitude.